Louder.
Set theory in modern logic. What is set theory? Set theory is a branch of mathematical logic that studies sets which are collections of distinct objects considered as a whole. These objects can be numbers, symbols, or even other sets. Sets are usually denoted by curly brackets and are fundamental to modern mathematics. A set of natural numbers less than 5 can be written as just start the curly brackets and 1, 2, 3, 4, till to 5. And what is that? A set is a well-defined collections of distinct objects or elements. These objects can be anything from this people, colors, etc. And each object in the set is called an element or member of the set. In origination.
Go.
Set theory was founded by German mathematicians Georg Cantor in the late 19th century, around 1874. Cantor introduced the concept to provide a rigorous foundation for mathematics and to study infinite sets, which became the foundation of
Guys, what is the time you people are?
Types of sets they have. Then first set is empty set, a set with no elements. Example, like curly brackets with any element. Then finite set with a countable number of elements like this. Then infinite sets with uncountable or endless elements like etc. Then equal sets with exactly the same elements. Then A, B, C, and this order may be changed like A, B, C, simply A. Equivalent sets with the same number of elements. Then singleton set, a set with only one element. Then subset, all elements of one set are also in another set. Yeah, it's maybe it's set A and set B. Then this A set is subset of B. Like 1, 2 is in the and also B. Then proper subset, a subset that is not equal to the main set. Then universal set, the complete set of all elements under consideration. Power set of all possible subsets of a set. Yeah, like the sets B, its elements are 1, 2. Then possible elements is maybe null set, only 1, and set 2, then 1, 2 together. Then disjoint sets that have no common elements. Then first set is 1, 2, then second set is 3, 4. They have no common elements. So that is disjoint sets. Then in set theory they have operations. First operation is union. Then symbol is this like U. Then A set and B set, A union B, meaning elements in A or B or both. Example A1, 2. Then the B set is 2, 3. Then A union B like get together 1, 2, 3. Then intersection A intersection B, elements common to both A and B. A intersection B like this common 1, 2 and 2, 3. Then 2 is the common element, so 2 is the intersection. Then difference A difference B, elements in A but not in B. Like we can difference from A minus B. So 2 is common, so that is cancelled. Then 1 is remaining, so 1. Then complement, A complement, elements not in A with respect to universal set. It's universal set. They have this kind of elements. Then A is the set, is 1, 2, A complement. So we remove the 1, 2 elements from the universal set. So 3, 4 is remaining. Then subset, this is the symbol. All elements of A are also in B. So like this. Then equality, sets A and B have exactly the same elements. A equal B. Then A set and B set are equal. Then what is a categorical proposition? A relates to classes or categories, asserting something about the members of those classes. So we have a code A, E, I, O. So the proposition type A is universal affirmative, then form like all S are P. Example, all dogs are animals. So its meaning every members of S is included in P. Then next code is E. It's universal negative. No S are P. Then example, no cats are birds. So no member of X is included in P. Then I, particular affirmative, some S are P. So some students are brilliant. At least one S is included in P. Then O, it's particular negative, some S are not P. So some cars are not electric. At least one S is not included in P. So it's a cryptographic thing. Then this is A, E, I, O. This is contraries each other, like this all humans are mortal. Then this is no humans are mortal, like opposite. Then this is subaltern, some S are P. Then this subcontrary is sub S are not P. Like that. Then this is contradictories. This all humans are mortal. This is some
You
humans
should
are
have
not.
put that score, no? Right? Score of opposition. I think you have mentioned in the slide. Then here, what is the problem? Should have drawn that, right? Should have drawn, right? Should have put it in.
Can I draw this again?
While you are preparing a PPT itself, while you are making all these things, should have drawn this square of opposition, right? Square. I am just talking about square. Go ahead. Whatever in the book or whatever, then you are not.
Syllogism. A syllogism is
No, go to like the previous one. Where is here square? Yeah, go ahead.
A syllogism is a form of deductive reasoning where a conclusion is drawn from two premises. Each statement involves a relationship between two things. The structure like major premises, the general statement, the minor premises like specific statement, conclusion, logical result from both. Then example, like all humans are mortal, Socrates is a human, therefore Socrates is mortal. This is an example of categorical syllogism using universal statement, like all humans are mortal, that's a universal affirmative. Then connection between syllogism and set theory. A categorical syllogism can be represented using set theory. Example, rewritten in set languages, all humans are mortal. So these humans are included in mortal, like that all S are included in P. So humans, this is a subset. So humans, the mortals, humans is a subset of mortal. Then Socrates is a human. This Socrates is equal to humans. Then conclusion like Socrates equal to mortals. So syllogistic reasoning can be visualized through set inclusion and membership, making abstract logic more concrete. Then De Morgan's law. De Morgan's laws are fundamental rules in logic and set theory that relate conjunctions, means and then disjunctions through negation. There are two main laws in De Morgan's law. The first law is negation of A conjunction B equal negation A disjunction negation B. Then second law is negation of A disjunction B equal to negation of A conjunction negation of B. These laws are widely used in digital logic, Boolean algebra, and other areas of mathematics and computer science. Can I draw that truth table? I like to draw the Boolean algebra. Then we have first set A, then second set B, then A conjunction B. Okay. This 1, 1, 0, 0, it's elements. Then here 1, 0, there is none, so we don't get both. So it's 0. Then again none is 0. Then again 0. Nothing. So it's the we get the results.
Plus, plus, plus.
Like acid, acid, disjunction, B, it's all, then 1, 0, 0, 1, 0, 0. So, like we got coffee or biscuit. So anyone we need. So it's both it's no problem. So 1. Then also here 1. So here also 1. So here nothing. So it's 0. This is the table. Q. That is the function. So De Morgan's theorem applying to classes. Two special classes are the empty class and universal class. Empty class is null class, nothing is there. Then universal class is everything is there. So 0 equal to empty class, 1 equal to universal class. So 1 complement equal null class. We already discussed the complement. Complement means opposite. Then universal opposite is null class. So some operations: A union, A complement. A means like universal. So A complement is null. So union means get together. Universal together null. So universal is the result. So we got the one. Like A intersection 1. That's also okay. This is a universal. 1 is universal. So A is the set. So intersection like A. So 1 have the A set also. So A is the intersection, the common thing, and it's the this dot is to the disjunction, no conjunction. 1 dot 1 complement. So 1 complement is 0, means null set. So 1 also universal set. So the complement became the conjunction. We got the 0. It is easily shown that any class can be designated by infinitely many different class expressions. The notations introduced thus far permit symbolizing that A and B subject predicate propositions. That E proposition, like E proposition, no A is B, asserts that the classes A and B have no members in common, which means that their product is empty. So we can written like A, B equal 0. Like that, this is universal affirmative.
So universal affirmative.
First, the second one is universal affirmative. So we have all A is B. All A is B. Asserts that there is nothing which belongs to A but not B, which means that the product of A and complement of B is empty. Because if we go A, B equal not B 0, because if all humans are mortal. So we put it B complement. This complement. So we got the 0. The two symbolizes the I and O categorical propositions. We must introduce the inequality sign, where A not equal to B asserts that either A contains object that is not a member of B contains an object that is not a member of A. AB not equal to 0 is I proposition, because in I proposition we have some cats are animal, like that. Something in the result. So it can be 0. So that is not equal to 0. And also in O proposition like some contradictory. We finalize that thing.
You draw that square, then you explain that how it is contradictory.
So it's contrary. Some symbols are noted. Subcontrary. Some humans are not wrong. These are all absolutely. This contradictory. So that means set theory, we find out this A B complement not equal to 0. Then this contradictory is equal to 0. This or proposition A B complement not equal to 0. Here if A B equal to 0, here A B not A B not equal to 0. Like this, in mathematical way we find out the contradictory things like this. So conclusion, set theory and De Morgan's theorems provide a foundational mathematical structure for understanding and analyzing categorical propositions and syllogism in logic. Categorical propositions such as all A are B or some A are not B can be visually and logically represented using sets, intersections and complements. De Morgan's laws help in transforming negative propositions like no A is B into logically equivalent forms, enabling clearer reasoning. This connection bridges mathematical logic and classical philosophy, allowing us to validate or refute arguments using systematic symbolical methods. These are the reference.
Go to reference.